Hi everyone, welcome to Flip Classroom. This is lesson 2, unit 7 on relations and functions. And today we're going to talk about relations. For this lesson, you'll see there's a lot of reading. So you can just read through it yourself and then I will fill in the example so that you could go through this lesson. All right. So first, it talk about a concept called relation. Okay, and then later on we'll narrow it down to functions. So relation is a more general term, just describe any relationship between two things. And then function, it has more specific meaning. So we'll talk about that later. So in math, we look at relationship between two quantities. Okay, for example, the value of computer to its ages, longer they are, it depreciate in price. And price of watermelon with its weight, heavier it is, more expensive it will be. A time taken for a person to walk to school related to distance to be walked. So again, relation is a mathematical way to relate two things together quantitatively. So comparison between two sets of data is called relation. List one more example for relation. So for example, the time you spend on studying, right? And then compared to, related to your grade. So relate two things together. Okay, representing the relationship between two quantity. So there's a lot of T terms here. So first it says there's seven ways to represent the relationship. Okay, you can describe them in words. You can make a table of values. You can show a set of order pairs, which are the coordinates. You can draw a mapping diagram. We'll see an example soon. You can write an equation. You can draw a graph. And also you can use function notation. Okay, so this is a concept that will be explained in lesson 8, 9, and 10. So we're going to use the following relation and show you all these different ways of representation. So the relationship we're going to study is cost of driving a car related to speed. Now, first we need to declare some variables, which are the cost, C, and then the speed is driven, at which it is driven. So one is called dependent variable, the cost depending on how fast you drive the car. So S is an independent variable, C is a dependent variable. The cost depends on the speed. All right. Usually we say the independent variable are the input and then the dependent variable are the result, are the output. And also we will talk about domain and range. The input, the independent variables are the domain. The dependent variable or the output are the range. So which mean what values do they take, the input values? What values appear in the input and output? So that's called the domain and range. We'll come back to this concept. Now, let's look at the relationships here. Now, look here. So if you drive at 20 kilometer per hour, okay, it will cost you $10 per hour, like per kilogram, and 30, like this is too slow, right? But then when you reach the speed of 70, which is like an optimal speed, it costs you less. But then when you push beyond that, when you try to drive faster, you're wasting more gas as well. Okay, so it's a parabolic relationship. So the table of values show you is one representation. You can put all of them into a order pair. Okay, right? Just write them right like this, right? Just put all of them in an order pair. Then you have the following. This is the order pair. Okay, and you can plot those order pair into a graph. Then you're resulting in this parabola. Okay, in this shape. Cost of driving relative to the speed is driven. So there, once again, there's a optimal speed that save you the most money. Finally, we have this called a mapping diagram. You list all the input value here, and then you list all the output value on C, and then you map them. Okay, and then here, since you can draw more than one arrow from each to each number, you can see you have less output because both 60 and 80 they consume like 7.6 dollar per kilometer driven. Okay, so this is the mapping notation. You just draw all the input, output, and then just point them. Okay, now this is a good way to show. So the range of data of the input are called the what? Are called the domain. So all this number here are the domain. Okay, and all the numbers here are the range. Okay, so we will talk about that later as well. Okay, let's moving on. And then final, like the other ways is you can write this as an equation. So this is the equation. Okay, this is a quadratic equation. We'll learn how to figure out this equation in grade 11. And then this is the graph. Okay, and then certain value doesn't make sense here. It says it doesn't make sense to say the speed is 5,000 kilometers per hour. So you can't drive that fast. Okay, so some value makes sense, some value doesn't make sense. All right, next concept, independent and dependent variables. The values of the independent variables represent the inputs. The corresponding values of the dependent variables are the output. So in order pair, the first coordinate are the independent variable, and then the second is the dependent variable, which mean what? Which mean x is independent and y is dependent. Okay, so xy, right? Independent, dependent. So like it's just show you what's dependent, what's independent. So you just read it yourself. Okay, when you write an equation, x is the independent variable, whereas y is the dependent variable. Whatever y is, it depending on what x you put in. Okay, so once again, read this information here. All right, and I'm going to show you some example. Diagrams show relation expressed in different ways. In each case, state the independent variables, dependent variable, list the input, list the output. All right, here, independent variable is P. This is independent. Q is the dependent variable. Okay. And then the inputs are 5, 8, 11. So these are the inputs. The outputs are 10 and 16. Okay, so when you put in 5, 8, and 11, you get 10 and 16 out. Here, V is the independent variable, and then A is the dependent variable. The inputs are 4, 10, 25, and then the output are 12 and 15. Okay, so 4, 10, 25 are the input, the output are 12, 15. You don't need to repeat, you don't need to write 15 two times. Okay, finally, the first one is the independent variable. So B is the independent variable. And then C is a dependent variable, because that's always the case. Okay, input are 3, 4, 5, and 6. And then output are 7, 11, 15, 19. Okay. Example number 3. So state the independent variable, state the dependent variable. Okay, so here R is the independent variable and C is the dependent variable. So like X and Y. Okay. And then here T is the independent variable, the x-axis, and then the height is the dependent variable. The amount of sap S obtained from a maple leaf is depending on the time a container is left attached to the maple tree. Okay, usually it says it's depending on the time. So S is depending on time. Time is an independent variable usually because time just keep going. So time is independent, and then all other things depends on time. So in here, S is dependent and time is independent. Okay, I will move on. So investigation relationship by plotting order pairs. So like read the information and then you can use the following numbers, plot it. Okay, so when I input a -2 to x, okay, X is all your input, and then you plug it in, and then you get Y. Okay, so plug in -2 to X. -2 times 2, -4 minus is a 9. Okay, plug in a -1, and then you get -9, you get -7. Plug in a 0, you get -5. Plug in a 1, 2 minus 5, -3. Plug in a 2, 4 minus 5 is -1. Okay, and then X and Y become your order pair. So you can just rewrite them like this. Okay, so this is your order pair. And now you can put that in a graph. Okay, plot those points in a graph here. Okay, so -2, -9 here. -1, -7. 0, -5, 1, -3, and then 2, -1. See, you just plot those points. Connect the dots on the grid to extend the line in both directions. So if you look at the relationship, they move every 2 blocks. So when you draw it, you go through this point as well, right? You see that? Like you go through 2 boxes, 2 boxes, 2 boxes, 2 boxes, 2 boxes. You draw the arrow, indicate it's keep going. Use the graph to determine the value of y when x is 6. Here we go. The coordinate is 6, 7. Okay. Use the equation to determine the value of y when x is 6. So y is 2x minus 5. Y is 2 times 6 minus 5. So 12 minus 5 is 7, as we see it here. Okay. So a relationship can be represented by a graph, by equation, by order pairs, by many different ways. Write the value of y when x is 6 in the table. Okay, well, use the graph to determine the value of x when y is 3. Okay, so if you go back to the graph here, okay, so we want to like make the graph match like this. The question say determine the value of x when y is 3. So you look here, you look at the graph when y is 3 here, x is 4. Okay, 4, 3. Okay, so I'm using the graph to answer that question. Okay, so 4, 3 is the answer. All right, and then you can like here 4, 3. X is 4 when y is 3. Okay. This relationship is called a linear equation relationship because the relationship is a straight line. So we'll learn about linear relationship in next unit. Okay, now this one is a quadratic, and then you can do the same thing. Okay, basically you plot all the points here. You plug in a 4, 4 square minus 6 is a 10. 3 square minus 6 is 3. 2 square minus 6, -2. 1 square minus 6. Okay, and then you just plot those points. Okay, so x squared minus 6. So if you plot those points on the graph here, okay, I'll show you the result. So this is the graph. Use the symmetry of graph or table to predict the value of y when x is equal to -4. So you can see it's symmetrical. So -4, there's one more point, is 10 here. Okay, so I didn't plot that point. So you can just plug it into the equation, you will see it as well. All right. And then why do you think this type of relation is called a nonlinear relationship? Because it's not straight line. Okay, it's not a straight line. Not a straight line. It's actually a parabola, it's a curve. This is something that we will learn in grade 11. Okay, so that's the end of this lesson. Hope you enjoy it, and then you can try the homework. Okay, see you. Bye.